Hello there, welcome to part 3. We just finished up with number 2 on this slide, and unfortunately when I restarted recording it erased everything, so we were right here where we just did these two questions, and this number 1 came out to be 6 times x minus 2, and we talked about factoring, and that we're doing the reverse of the distributive property at this point. And you can check it by distributing that and see if you get what you started with. 6 times x is 6x, and 6 times 2 is 12, with the subtraction sign in between there. And number 2 came out to be 3 on the outside. That was the greatest common factor of those three terms. And we had 1x minus 2y plus 3, because all we did was we divided each term by that factor there. So we go to number 3, and we look for that greatest common factor, and see if you can see that that is actually you got 16, 32, and 48. The greatest common factor of all of those numbers is 16. And it's interesting here because you might have thought it was 8 or 4 or even 2, but the point is you want the largest one, because when you factor it, you're trying to get the largest factor out. So I am going to divide each of these terms by 16, the greatest common factor. There. So if I do that, remember how we write the answer. We write the factor on the outside, and then we divide it. 16 divided by 16 right here is 1a, minus 32 divided by 16 right there. That comes out to be 2b, plus 48 divided by 16 is 3 right there. And if you want to check it again, multiply it back. This times this, that, etc., etc. So that, again, is called factored. All right, now, to try to make a point here, this form, and what we're doing here, we're doing it this way because the instructions says to factor. All right? Now, if the instructions were simplify, we would actually be, this would be our answer, what we started with. Okay, and then what they would have given you probably the other form, the factored form. So to simplify means get rid of those parentheses, okay, and then add your like terms together when you can do that. Okay, and number 4, lastly, a greatest common factor here. Now we've got negative 12, 32, and negative 16. Well, the greatest common factor there you could say is 4. So if I divide out of 4, now let's watch what happens here, because some math teachers might ask you to do it slightly differently, but let's just do it this way first. If you divide negative 12 divided by 4, you get 4 on the outside, and you have negative 3x plus 8y, and then you have minus 4z. And that's okay. There are some math teachers that, or as you move up in class, some teachers, well, let me change color here to try to make a point. Some teachers that want this first term inside to be positive. All right, they don't like that to be a negative number. If that's the case, all right, another way to do this question would be to divide by the GCF, and instead of using 4, you could use negative 4. Okay, so watch what happens if I went back and did this problem, but instead divided by negative 4 on the outside. Then you would do negative 12 divided by negative 4. That would make that positive 3x. You see how I did that? I just divided negative 4 here, where I originally divided positive, and you would need to do that to each term there. And then if you did that, essentially what's going to end up happening is you're going to just basically reverse all the signs of it right there, and then you end up with that answer right there. So at this point where you are, I'm not overly picky. Oops, I forgot the z. Sorry about that. I'm not going to make a big deal of whether you make it positive or negative. I just want to see that you can get the factor out and that you can make that part in the parentheses more simplified than it originally is there. So, oh, and there come the answers, and I forgot I had those over there for you. So that's factoring. So we had simplify, which is get rid of the parentheses. Okay, factor, which is, you know, make the simplified form into that factored form with the parentheses there. So moving on to the bottom of page 5, let's talk about, this is actually something that we've already talked about, sort of. Like terms. Like terms in an expression are those whose variables are exactly the same. Okay, this includes the variables and the exponents on the variables. Now you're really going to see this part here in your later classes where we have different exponents and being able to identify whether or not terms are alike based on the exponents. But let me try to make a point here. Let me do a little t-chart here. And let's say I have a term, okay, and let's make a like term here. All right, and let's make another column that says not like. Okay, let's say I had a term like 5x. A like term of 5x would be 3x. Why? Because the variables are exactly the same. A not like term would be anything that wasn't with an x. Maybe it's 2y. Okay, that's not a like term with these. Okay, it's different. It doesn't matter what the number in front is. Let's say the number was -1/2 y. Okay, a like term could be 6y. Again, it's really all about the variable. Now watch this one. Here's a not like term. Let's say I had 7xy. Not like, and you might be thinking, but there's a y in there. Nope, it has to be exactly the same. xy is not the same as y. So it's almost like the variable is its name and they have to be identical. Okay, so if you have, why is that important for them? When you have like terms together, okay, you can add them. And that's what we're going to see on the next page here. Okay, you're allowed to add like terms and only like terms, so, or subtract. So in this particular question, number 1, what I like to do is I like to underline if it's like. I have 6x minus 3x. This has x. I can underline that one because it matches that. So 6x minus 3x is equal to 3x. You can do that. Okay. Number 2 says 7x minus x. Now remember that's really just 1x. So 7x minus 1x is equal to 6x right there. Now take a look at number 3. I have 5x. I'm going to put one line under that. I'm going to give myself a little visual cue here. And I've got 4y here. Now 4y is different. So I'm going to put 2 lines under that because this one's name, or this one's variable is y, this one's variable is x. Now I've got minus 2x, so I'm going to change that to addition because I don't like subtraction, plus negative. Now this one, negative 2x, matches 5x. So I'm going to put one line under that. And this y is a y, and it matches this term. So I'm going to put the matching number here. So I can take basically 5x minus 2x and end up with 3x from these two, this one and this one. And then I have positive 4y minus y, minus 1y. Positive 4y minus 1y. Okay, 4 minus 1 would be 3y. And there you saw the answer come up right there. Okay, so it's about identifying like terms, okay, and adding only the like terms together. Don't add different terms. You can't do that. Okay, so if I'm on number 4 here, again, I like to change all of this subtraction to addition. 3x minus 7x. I'm going to think of that as plus negative. Minus 11, so that's plus negative 11 there. Plus 8y. You want to leave that one alone because we like addition. We don't like subtraction. Plus 4 plus negative 13y. So I'm going to add these two together because I have 3x and 7x. So 3 plus negative 7x would be negative 4x. Right? So those two are done. I'm going to hold off on this one because typically what we do in algebra is we write the variable values first. So I'm going to do this. Okay, or again, I was using the underline. So for the y, I'm going to put 2 lines. These two are matching. 8y plus negative 13y. That's negative 5y. And then the 11, I'm going to put 3 lines under that because that doesn't match x, and that doesn't match y, but it does match this 4. So these two are matching. Those are like terms. So I have negative 11 now, plus negative 4. And that would give me negative 7, and just negative 7 right there. So you can actually write that answer either way like I did, or you can write it as subtraction signs this way, or this way right here. So hopefully that makes sense to you. But the key point of that part of the lesson is only add together or subtract together terms that are exactly the same, like terms. Okay, so we'll hit the stop button here, and we'll get going on the next one shortly.